In the figure below, OA is A vector and OB is B vector. A point P divides OA in the ratio 3:1, and another point Q divides AB in the ratio 2:5. If OQ meets BP at M, determine the ratios OM to MQ and BM to MP. So let us key in the information that we have. We have that OA is A vector. We already have that. OB is B vector. We have that. And the point P divides OA in the ratio 3:1. So P is here, and it divides OA in the ratio 3:1. So it is 3 and 1 there. And another point Q divides another point Q divides AB in the ratio 2:5. AB, so Q divides this in the ratio 2:5. So if OQ meets BP, OQ meets BP at M, so it means we have M there. Determine the ratios OM to MQ and BM to MP. So we can express the parts that we do not have, like OM. So if we take that OQ is the whole thing, which is 1, we can take OM to be some fraction of OQ. So we can let it be maybe K. So if it is K and the whole thing is 1, it means you have 1 minus K there. We can also take BM to be a ratio of BP. Let's say it is N, so that the rest of it will be 1 minus N. So it means the ratios that we have, OM to MQ, is OM is K and MQ is 1 minus K. The other one that we have is BM to MP, and BM is N and MP is 1 minus N. So the next thing that we need to do is just express one of these vectors in two different ways. So we can take OM and express it in two different ways. The first expression, we can use the ratio theorem, so that we have OM is the same as N over the total, which is 1, N over 1 of the alternate vector, which is OP, and OP is 3/4 of A. 3/4 of A plus 1 minus N over the whole thing, which is 1, times the alternate vector, which is B vector. So if we simplify this, we're going to have 3/4 N A vector plus 1 minus N B vector. Then we can also express OM as a fraction of OQ. So we can say OM is equal to K of OQ. So it means we need OQ. So we can also use ratio theorem to obtain OQ. So OQ is 5/7 of the alternate vector is OA, which is A vector, plus 2/7, and the alternate vector is B vector. So it means OM is equal to K of OQ. K of OQ, and OQ is 5/7 A vector plus 2/7 B vector. So if you open up that bracket, we're going to have 5/7 K A vector plus 2/7 K B vector. So this is OM and this is OM. It means the two vectors are equal. So we have 5/7 KA plus 2/7 KB being equal to 3/4 NA vector plus 1 minus N B vector. So the next thing we need to do is just compare the coefficients of A vector, and then we compare the coefficients of B vector. So for A vectors, we have 5/7 K being equal to 3/4 N. We call that equation 1. And then for B vectors, we have 2/7 K is equal to 1 minus N. You can call that equation 2. So we need to solve these two equations simultaneously. So we can use substitution method. So from equation 1, k is equal to 3 over 4n times 7 over 5. So it means k is equal to 21 over 20 n. And then from equation 2, k is equal to 1 minus n times 7 over 2. So it means k is equal to 7 over 2 minus 7 over 2 n. So these two are k, so we can equate them so that we have 21 over 20 n is equal to 7 over 2 minus 7 over 2 n. So we have 21 over 20 n plus 7 over 2 n is equal to 7 over 2. So if you sum these two, you're going to have 91 over 20 n is equal to 7 over 2, so that n is equal to 7 over 2 times 20 over 91. So if you take this product, you're going to get 10 over 13. And then k, we can pick any of these two expressions for k. So even if we take this one, k is equal to 21 over 20 n, and we have n as 10 over 13. 10 over 13. So that should give you 21 over 26. So now back to our ratios. We have OM to MQ, and that was k to 1 minus k. So we have k as 21 over 26. To 1 minus k, that will be 5 over 26. So because the denominators are the same, just take the numerators. So you have 21 to 5. Then the next ratio that we have is BM to MP, which we expressed as n to 1 minus n, and we have n as 10 over 13. So that 1 minus n will be 3 over 13. So because the denominators are the same, just take the numerators as 10 to 3.